everybody, and welcome to Rocket Lasso Live, Season 7, Episode 7. How is everyone doing today? We've got some people over on Twitch. We got at least one person on YouTube. So we're going to wait for some more people to show up, but start getting those questions put together. Okay, important news to mention right away is Jonathan Winbush was going to be joining us today, but it turned out he already had something he had to do. So we have rescheduled it to next week. So no change except for pushing it back a week. So you've got extra time to get those Winbush questions put together. And I think he's actually on the Mograph.com podcast yesterday as well. So he's making the rounds right now. How is everyone doing? I hope everyone is doing very well. Dean got a question up right away for us. So let's go ahead and check that out. It's a link to Instagram. And thank you for quickly compensating for a non-Winbush based question. So let me go ahead and click on that. I'm going to scope it out real quick. Oh, interesting. Wait. I have to frame it bigger. I'll switch the monitor in just a moment. Okay, so let's go and switch over to here. And I'm going to hit refresh. Oh, and probably mute that tab. Okay, so we've got a disc sander, and somebody's just grinding some crayons directly into it. And eventually you can see that, it's colorizing the sanding disc, and then all this excess material is getting pushed away. I mean, there's a lot of different elements here to potentially, talk about, where it's like, well, here's like this shape getting pushed inside, and it kind of starts falling apart after a while. But the, it's like like we wouldn't be making this real. You'd be doing a series of elements that are all kind of faked. I guess, Dean, if you have a specific aspect of this that you find interesting, like, let me know. I do like these real life ones. This is from a satisfying ASMR. Maybe there's some audio on here, but we're not going to listen to that. Yeah. Yeah. Okay. So I'm thinking we could do some vertex map stuff. You potentially could do some Boolean stuff, but at the same time, what's making that look interesting there is that's disappearing and through, already disappearing into the sanding disk. But like, for our purposes, if we just pushed that straight through the geometry and didn't even worry about the bool, there'd be no visual difference to it. So I don't even know that erasing those out would make a difference unless you were going to pull them away after the fact. So yeah, there's definitely some elements we could go and start tinkering around with here. If there are other specific elements that we are interested in, please let me know. Because you also have this like strip of kind of melted wax pushing up as well. And each of these are sort of a different thing. So switching back over to the laptop, here we are in 25.2.1. And let me make sure I get the chat windows back up again. And yeah, Dean's specifically interested in the way the colors transferred over to the other, into the disc sander. So yeah, let's tinker around kind of quickly with this, because I'm trying to think of any aspects that I think are going to be complicated. We can make a simple disc shape easily enough. And then I think this is what's going to be taking on the colors. So yeah, let's spend some time making sure that we give this plenty of subdivisions and a decent amount of these radial ones as well. And we're going to need to spin this. I do want it to kind of spin forever. So this is a good opportunity to use a field driver, and be that the Rocket Lasso field driver or a Maxon field driver. So we are going to be driving what parameter? It's probably going to be B. Yeah, so we're spinning B. So we could right click and say field driver, add field driver. And that is now driving the rotation. They do give you a custom icon for that rotation. And then we are going to say what the angle should be in the end. And under fields, I'm going to make a rocket lasso. So if you have the field driver field pack or field bundle, I'm going to be using the rocket timer. So now this timer should be feeding through that entire system, and it's saying to have that spin around. I'm going to grab the axis so we can actually see this. You can see that spinning around, but the timer makes it really easy to say how long it should take to do the entire loop. And I'm going to say it's going to loop, but cumulatively add all those together. So now no matter how long our timeline is, this should keep on spinning as soon as I unclamp that. So that will spin. Now I want to select this so I can actually see how fast it's spinning, because the actual thing is spinning insanely fast. So that's something we should keep in mind, just so we can kind of visually see. I'm going to make this sphere, scoot it up, and now we can see how fast that's turning. Now the actual disc sander is probably spinning insanely fast, so we can go into these parameters and say that's actually going like 360, and now you can see that's now going quite quickly overall. At a certain point, it doesn't make a difference, and for our rig, I don't know that's going to make a maybe it makes a bigger difference, maybe it won't. We can always come back here and tweak these parameters if we need to. I'm going to shrink the sphere a little bit, but we will keep it there just so we can constantly be getting this reminder of, you know, the animation, how fast it's going, so we can use that as a variable. Let's go ahead and give me one split second. And let me just make sure I don't have a, nope, that's fine. Making sure I didn't have a bad folder showing up. Episode 7, scene files, and as always, a reminder that all these scene files are available right after the live stream to people supporting on Patreon at the engineer tier. Let's see. Crayon to sanding disc. I mean, that's fine. This is quite literal. I like being literal with the names. So yeah, we got the spinning, and now we're going to need several different shapes. See, this is where, so I want to do a test. Even I'm actually going to temporarily turn off this spinning disc. So I'm going to say, don't be enabled. Actually, even better, instead of turning that off, I can just turn off this timer, so I can just turn on and off this checkbox. So now we see this as a vertex map. My first idea, something I want to test, is if we make a matrix object, we'll make this 1 on Z, shrink this down, scoot this over, and drop this down to, I don't know, let's say 8 steps in between. Change that to endpoint. And then let us make a step effector. Step effector, don't affect the scale, but yes, affect the color. And under, oh yeah, we need to do it as a field color. Oh, yeah, I did that. We almost never need to use something like a step effector. What we do instead is use a plane effector with a step field inside of it, which I should have done here. So yeah, there's step field. So same idea. I'm going to say affect the color, and now the step field, which actually only exists as a field, it's not an object. It's a field. What do they call these? These are field layers. We're going to give it, yeah, it's got remapping. So we go to color remap. I'm going to say gradient, and now I can go inside the gradient and grab something like rainbow 2. And now we've got the gradients of colors across there. So now that that's happened, if we add a color vertex map onto the disk, and I will grab this and shrink the visual radius way down. Can I drag this in as a Mograph object? Okay, you see colors did come through. That's good. Selecting this, and I say, give me, that says based on the nearest, which I suppose makes sense. I'm going to say, is it the max range? And then we make that range pretty small. Yeah, okay, so max range, give it this little color fall off, and now we can see that we see some colors there. Let's give this, presumably we just make a base color here, although this could mess up stuff later. But yeah, now you see it's everything white. Everything is white. We could make it kind of like the sand disk kind of red if we wanted to kind of mirror it. Now the question goes to, now this vertex map is live hanging out there. But what I want to do, and this is where maybe this color thing will mess us up, so I'm not worried about that aspect yet, is to what degree can we use a freeze to remember this? So if I say freeze, and we're going to not make it grow, so we don't use these other modes very often. I'm going to say max for now. and nothing's moving. But if I activate my timer here and I hit play, okay, nothing's sticking yet. So freeze, max, auto update. Oh, okay, auto update. As soon as I turn on auto update, you see it did start working. So like the first time this goes through, you see it is going to draw on. The disc is passing through and it's getting applied. Now, interestingly, you see that we're getting a very distinct pattern applied here because our spinning is on some very even increment. So it would probably, it might behoove us to put this onto a irrational number of some sort. But even now, I'm not sure what a good number would be. Let's just say like put a 7 on there, which generally speaking will add in more randomness. And now I think that the will pattern maybe a little bit less, but maybe I could be wrong. Even if we did maybe a decimal on there, 0.3, 367.3, just out of curiosity. You still kind of see the patterning. But before we even worry about that, I don't use max very often. What if I set that to add? Okay, okay, now that's constantly adding and getting brighter, which is kind of something I want, but I think I want it on normal. Auto update was needed. So I think the main thing I want to do is the effect strength, but will that work? So if I say 10%, no, see, that seems to still get applied 100%. What is this radius going to do? Yeah, that's the max value. How can we have this constantly get a little bit more applied? It's technique that we've kind of done before, and I always can't just do a delay, although that would something with some decay. No, not delay could. It's interesting. The freeze could make it look like it's fading in a little bit more. That's not quite what I was expecting. That's not at all what I was expecting. There's some, I'm almost certain there's some sort of combination we can do here. If I said add, well, what if we say max? Okay. And then we pull way back on the incoming matrix object. Okay, I think that is doing what I wanted. So we're saying, yeah, what is the max value? And it's constantly seeing kind of its value itself, and then it's adding up on top of this matrix object. And so that means every time this does a loop, it's adding a little bit more on to the layer before. So I don't think this effect strength means anything. We say 100% effect strength, and that doesn't change anything. This radius might, yeah, this is going to kind of be a blur on everything. So honestly, I don't even know if we need any radius, because the entire radius can be driven thanks to our matrix object. And now you can see that as it loops around, it's getting applied more and more and more. So that's the key part of this rig, is it getting more and more color, and the amount it's going to be getting layered on top is going to be based on whatever this percentage of the matrix is allowed to be shown. And of course, that is being shown through that solid layer, or it's being shown on top of whatever came below, which is why we put it back to the color black. But now we can see this all getting applied, and you can see now that we're down to 2%. That's barely there, and we get more, and then we get more, and then we get more as it's looping around. So let's hit that so we can actually see that a little more clearly. We've got the matrix that's going to be getting fed through, and this is based off of a radius, and we have a distance fall off. So if we go to yeah, it's just a distance fall off. If I turn that off, is it just solid? Okay, yeah, well, that just makes it solid, but it's very, there is no fall off. What's funny is that you don't get a remap. Look there. Oh, wait, there is remapping. Okay. remapping, enable remapping, and then I want to do that, which might look identical. No, that's okay. So essentially I want to make sure that this radius is the correct radius for how these should be essentially just fully butted up against each other. But I'm not sure. It's kind of tricky. Let's turn off the freeze, crank that back up again. And you see that we are kind of getting them fading out a little bit. We get this dark blend in between them. The min, the average. I feel like it'd be the max, but I gave it no fall off. But you see that, I guess if I push it up about there, that seems to kind of do it, but we might cross blur a little bit on top of each other. Anyway, that's the thought. So now we can always double click on this and type in a number. So 2%, and now they're slightly getting applied layer by layer, a little bit more than the one before. So let me think of additional layers to this. Okay, so if we wanted that red color, this is set to max, and it might be only being applied below. And we have to mask it out too. So I don't really have a good idea of how we could make, if we want the whole thing to be red before it turned this color, I think we need to like also be generating some sort of alpha separate channel and layering them together. It's a lot of just tag math that I don't think would be super interesting. So I don't think I'm going to worry about that aspect. But to complete this illusion, we probably need to clone. I'm going to make a duplicate of our matrix and then use the handy Mograph swap cloner matrix. I wish it renamed it to cloner. And now I've got all the exact same settings and effectors and all that getting applied. So I suppose a simple crayon model is incredibly simple to make. So let's make a inside 64 sides. Throw this into a loft, which also can get like 65 sides. I think you always want one higher. Maybe it's one higher and lower. You see right now I'm just not worried about scale. I'm just going to eyeball, see what my memory of the shape of a crayon kind of is. Oh yeah, right now it's organic. I'm going to say don't be organic. So yeah, now we just have the literal. So yeah, that goes in a little bit, and then do something kind of like that. Grab these three, make it longer. Cool. That'll be the crayon. T for scale. Put that into the cloner, and now we've got a bunch of clones of it. T for scale. And look, they're the right color already because I already had the same effector applied to it. So I'm going to make it look like they're all pretty much just barely touching. And so it depends on how fancy we want to get, because the colors still are based off the radius here of that. And, we could build a rig. I'm trying to think. It's like if we made both these like a child, where it's like I could animate this in, and then like once this touched, that matrix could stop moving and we could keep pushing the crayons in. So we could just do two separate sets of, to do some sort of clamping there. I think we'd probably end up needing to do espresso. So let's just do two separate sets of keyframes. So keeping it simple. In fact, I'll even just set this to linear to start out with. Animation, linear, Control or Command D. Go to animation, linear keyframes. So let's eyeball this so that is right at the tip of the matrix. Although I think we want to push it back a little bit. That can get modified later, but keep in mind that the matrix has a radius, so it's actually going to strike before the actual matrix object gets there. So this is now just us keyframing on X and hit play. And right around there, we can say it's fully like to where the matrix about, thereabouts would be. Keyframe it, and it's going to start giving the color. And then we can, I don't know how long this should take, but let's go to 300 frames. And we'll say that that just kept on kind of pushing right on through. Now, when it came to the sand disc, the obviously the crayons were getting melted away. So here, and there's a lot thicker, so you couldn't really see that they were passing through. Right now, we're just going to let them pass through, and then it's such a simple model. We could probably do some sort of Boolean. Oh no, why did I do the thing I always do, which is I didn't record my initial keyframe? That one's recorded. This one's, I was recording on X, and it turns out it's on Z. That was not what I was expecting. Not at all. Okay, let's try again. Keyframe that. Go forward some frames. Go in. Record. Go forward. Record. Okay, that looks a little bit better. All right, let's see. Oh, wait, we're not going to see anything else. I have this selected. So they get in contact. The colors instantly start going. Those look like they're getting pushed in. That's constantly becoming more and more solid. Now it does get to, like, we still got that little transitional bit right there. Some of that could just go to like our subdivisions maybe, or these different blending modes, and maybe we could be really particular. We could grab this disc shape and give it more segments, which looks pretty crazy when the data updates live. It's interesting that it's like, I think the purple is there, but all the other ones are quite vibrantly there. And the purple, this is definitely dark, brighter than what it's getting portrayed as there, which is interesting. Now, I would like those to be sharper. I think we've got like a majority of the effect working pretty well. And then I'm also curious of, like, our colors are coming from the cloner, but in order to do a Boolean on this, I feel like we'd need to bake it down, in which case we lose the colors from the cloner. So do we actually animate something internally and have that bool outside of it? Or can the new bool, now as soon as I put in the bool, it loses the color as well. So unfortunately, I think in order to make, if we want to take the bite out of it, we actually need the bool to be happening internal to this. So let's reset those and then keep it simple. We'll make a big old cube. I'll oversize it just to be sure. And let's just, and again, we're continuing to just like kind of eyeball this stuff. So I'm going to scoot that there. It's A subtract B typically. So A subtract B. So now each crayon should independently be getting Booleaned. So now we actually have to keyframe this crayon object. So we keyframe that, and honestly, I'm just going to eyeball it. It's fine. And then I see they just disappear, so we can go all the way to there. Heck, we can go all the way through. And keyframe. The bool is taking a little bit to calculate there, because that seems to be the primary thing that slowed it down. The colors get thicker. Of course, we could have those colorize up quicker if we wanted to. That just goes to this matrix percentage. So we say 5, so it's going to be more than double. So as it passes through, colors will fade up significantly quicker. I mean, what's interesting here is like in real life, it's like this really impressive effect, but here I feel like we're doing something like incredibly straightforward for all purposes. Like technically, like one side here is brighter than the other side there, but since the crayons are blocking it, we don't see the transition. So really, it's almost like you just have this gradient here, and you can just fade up from it, like just keyframe the gradient slowly fading in. Um, and yeah, after that, I mean, I'll give it a save, but I feel like we're kind of reaching the end of it here. There's not that much crazy stuff to do. And it just kind of goes to, we've talked about like this fade out, which visually is a little bit tough to see. Here it is at 100%. And our little decimal output there, I think, is enabling it to match them up a little bit better. But I can't think of a way that those could be fully. I got to turn off the wool for a little bit. Yeah, it's just these little lines that are kind of in between it that I'm not super into. But I'm just not 100% sure on what we could do to change that. If we grab just one clone, oh, and of course it's purple. Yeah, there's still some fall off on there. So maybe, give me a moment. Let's invert the colors just so that that'll be a nice bright red for us. So that even that by itself is still got a bit of a fade out to it. So I thought that this remap would remap, but let's see if we change that to be a full fall off and we say remap it to not have a fall off. I don't see a difference between those two things. So maybe remapping's not doing anything. So if we went back to the layer and we say have no distance fall off, now it's 100%. And you see that once it actually has gotten to go all the way around, that eventually these will get solid based on our rotation kind of offset. So now let's shrink our radius. Let's see what the exact radius is, which is about 2.6. So back into the vertex map, change the radius. It might need to be doubled. Yeah, I think we need to double it. Yeah, so that's pretty dang close. The disc shape, we already have a lot of disc segments. I mean, we can always increase it. There's not like a ton here. And yeah, so that's going to give us kind of some pretty solid circles. Honestly, here I'm going to just start eyeballing the radius because we want it to be essentially as large as it. We don't want it missing a gap. So I'm going to go as far as 7. And now if we go back and say, give us all 8, is this going to fill them all out eventually? And yes, it does eventually fill them all out. That's odd. So what's going on right here? Like purple, blue, blue, and then kind of this weird half stripe. What would cause that? Maybe that was probably just a previous run because now it looks like it's correct. Okay, that's actually incredibly accurate. So now let's go and drop our matrix way down. So, let's try again 2%. And hopefully now, because it's getting applied so mildly, it's very scrappy looking. Like it's all going to eventually get applied, but yeah, see, it's slowly fading up. I thought that would look a little bit cleaner. or it would get applied because we're applying so little, but it's even that little bit is still getting very intermittently applied. So that's a bit of yeah, that's not bad, but it's intermittently applied just based on the rotational speed. So it goes to kind of in reality to make this look really good, we need to essentially be doing subframes. Does that make sense? Let me. Okay, this is kind of an interesting direction to take this. Um, so okay, what am I trying to say? Okay, so what's happening is it's only getting a certain resolution applied on here. It looks kind of cool in its streakiness, but that's not what I want. So what we need to do is essentially have more subframes, but there's no way of doing like subframes inside of Vanilla Cinema. But what we could do, and I don't, where do we even do this? Where are these settings? So that's not what I want. Do we just go to our this would be weird. I'm not even sure what the end results of other things would be, but do we increase our FPS like dramatically? Like this would be insane, but I could say give me 300 frames per second. So now like it's still going to be playing just as fast in theory. But now there's 10 more it's kind of like adding sub steps inside of our simulation, but now we're having to do it because we have a fast spinning disk and we're only sampling so often. So now is everything playing back? Ooh, look at that. So yeah, with all those additional samples, that's working well. And you see that our frame count is like dramatic. It's going up really, really fast, I think. 300 FPS. Am I missing something? Because this feels like it's spinning slower. But the colors are getting applied really well. The matrix needs to get there a little bit faster, but oh yeah, and then so that's getting applied and it's 300 frames per second, which also means that this is being applied 10 times as much. You see it's quite visible quite quickly. So we need to actually also grab the blending here and set this to like 0.5 to make it 1/10 of the amount. So now as that passes through, yeah, it's faded a lot more, and now it can. Yeah, there's a second pass, and you literally see the passes as it goes on top of it, and eventually these will all layer up really nicely and become those same solid colors, which is exactly what we saw in the reference. So for all purposes, this is exactly what I want. You could slow the frames down further and get even more resolution here. We could potentially add like one layer of blur on top of this if we wanted to. Of course, you wouldn't get that really nice transition that we will eventually get in between these layers. As they all stack up on top of each other. Even here, I'd probably want to maybe increase this a little bit quicker because that's taking a while. And then would it, I think the calculations would still work, but if we were to render this out, I think we tell it to render at 1 frame or at 30 frames per second instead of 300. So the calculations would still happen, but the final animation wouldn't. Now I just want to get the matrix. Oh, it was like, why is the timeline so far out? Oh, interesting. Okay, so those all stayed on. Oh, I guess they moved to some different times. The playback speed is still 300, right? But let's drop this back. I mean, yeah, I don't know. I haven't done this type of. I haven't done this type of like frame manipulation very often, so I don't have a great intuition for it. But yeah, now the matrix gets there a little bit quicker, so that helps. Let's make a quick redshift material on the disk shape so that we can feed it the vertex attribute into the color channel. And that gets fed the vertex color. So now that should be, actually, yeah, now I don't even have to have it selected. We can see we get the final color applied. And then, is there much more to do? Let's reactivate our bool, because that won't really matter in the context of the animation. So now if we went back here, I'll just say all frames, we'll stop it obviously. And our frames, use the project frame rate, which is 300. I'm gonna say no, please use 30. Will it see our higher resolution? I just want to kind of have a beginning to end solution for you here. So we're not even really going to save it. Oh, and advanced redshift 0.75. Beep. Okay, so. Oh, it's shiny. I don't want a shiny sanding disk. It's actually going to be quite dull. All right, we're not going to see much until the crayons get there, but it shouldn't take too many frames. So this is back down to being about 9,000 frames, or 900 frames instead of 9,000 frames. It's interesting that you get that little, while it's rendering, we're getting like this little blinky bit here, but I don't see that represented when we actually see the final frame. Should we be seeing something now? We're 30 frames in. I feel like we should be seeing something. I feel like we should definitely be seeing something. Stop that. Hit play. I mean, yeah, we're messing with these frame rates, so that's got me a little bit worried. Yeah, I see something there right away. Now, if we open up Redshift and render, there is something there. Are our frame shenanigans stopping it from working? Because right there, it does represent almost exactly like it is in the viewport. Because you certainly, I'm going to say force pre-roll. Yeah, actually, let's just try that force pre-roll, which is a very new setting. I could actually imagine that doing something here, but yeah, I don't feel like this is actually going to work, because again, you can see that render is implying that there is some sort of something going on there, but once the frame's actually done, we're not seeing the effect. And if it's not essentially applying it 10 times in a row, if it doesn't get applied like 10 times layered up on top of itself, then we're only applying like we're applying only 1% of it there, in which case it would probably be so faded that we're just not going to be seeing it at all. So it would take, I think, forever for any color to come through here, which is annoying. Now, I think that this is super dangerous as well, but I'm wondering if we can bake out our vertex map, which is not a trivial thing because there is no inherent bake when it comes to those tags, but I think you can bake those out to Alembic. So let's see how far, we're doing this, our long version here. What's going on? Why shouldn't we be? Did I click something? Why is it suddenly not getting applied? The matrix moves into position. The disk is spinning. The vertex map. Oh, I clicked on property. Those are different. Those are different modes. So property. Okay, yeah, that was my mistake. So here's the problem. Oh yeah, what I wanted to do is see how many kind of times around we need to see, because if we're baking this, we're baking it at this insanely high frame rate, and this thing is crazy subdivided. So that could be like enormous. So let's give it like 1,000 frames. Even that, I'm a little worried about the baking time, but I'm curious if that'll work. I'm not sure who or if anybody's tried to do baking as Alembic in this type of scenario. I'm gonna save this another version. But let's right click and go to bake as Alembic. Let's go to the settings, and I'm gonna say, yeah, vertex. Here's all the different things it's going to try and bake out, and one of them is the vertex colors. So it's the only thing that exists. So we'll actually, yeah, that's the only thing I really care about. But I guess we can let it kind of do everything. I'm not sure how it's going to deal with the field, but let's see if this is reasonable. Yeah, that seems to be moving maybe about as fast as the timeline was, maybe even a little faster. I'm curious, as soon as I hit save, how large the scene file suddenly gets. Because this might, who knows? This could be 100,000 points getting a vector recorded on 1,000 different frames. Like, that's that's a lot of information there. I'm No, that wouldn't work. I was just wondering if there's like some completely alternative like tracer method we could do, where it's like tracing the circle as it goes around, which we could do, but that wouldn't, even if we let the tracer go around and around and around multiple times, that wouldn't be adding additional bits of color on top of it. Anyway, let's just kind of scrub in. Yeah, okay, you see that now did successfully bake in. That's the one that's showing. This color should still be saying that baked version of the vertex map, which should still have the same name. So now when I render, I would think that we'd see the color. Yes, I see it. So, okay, essentially the process does work, but we had to bake it. Maybe I'm missing something. I don't know what I would be missing, because that all seems correct to me, to make it work without having to bake it. But now we have the smooth version of the colors, each getting applied, and we're still running at our regular frame rate. Wee. There's a lot of different layers we could do here. That'd be kind of fun. One would be like make sure the crayons are a little bit offset from each other, and the matrix, of course, would have to be as well. And then they'd each strike at a slightly different time, and then the stripes would kind of begin at slightly different times. Like artistically, I think that variation would add a lot. And then these are getting now. I will say we slowed our disk way down, but like in reality, this is going around so fast, 100 times faster than we're spinning ours around. So this is kind of what it would look like in real life in super slow motion, that each layer is like adding on another pass. But in reality, that's spinning so fast and so much motion blur that this effect just looks like they're fading up. So honestly, that even starts to go back to like maybe this effect is merely like a total fake, and we just would slowly animate up a gradient, which would be a lot simpler than a lot of the rig we did. I liked us pursuing this vertex map route, but the actual effect we saw, this would be spinning around 100 times faster. So yeah, I think faking it even more. I tried to build it the real way. But in order to get what we really want, I think we'd have to fake it. Now I am curious about the file size, so I'm gonna hit save there. And let's jump on over here to episode 7, scene files. Oh, there's the Alembic. I was like, wait, that's not that big. There we go. We have almost 200 megs worth of Alembic file there. Not as bad as I thought it was going to be, but I don't want. Yeah, I'm definitely not going to include that aspect. I'm going to delete that. Oh, it's in use. I'm going to delete out this Alembic, save the file, and then close the file. And now hopefully Windows will let me delete that. Yes. Okay, yeah, we can't. I can't have the Patreon file having 200 extra megs in there. Let's see. Yeah, thanks for the question. It was fun. Maybe we could tackle some other aspect or try some different ways. But like I said, the alternative way with the tracer line going around it, and potentially that could be going way faster, would it wouldn't layer up. There's no, like, the vertex map merely sees the radius of the spline, and that you saw the way we did the max layering. Like, that wouldn't count if we layered multiple splines on top of each other. I thought I saw a question over on YouTube. And just a reminder for everybody that Winbush could not make it today, so it got rescheduled to next Wednesday instead. Skylar, when you are using fields, is there any way to visually see the data to see what it is doing? I always get confused with max and screen and others, and I know C4D adds an inspector doesn't show data. Well, the C4D inspector, as far as I know, that's just something with nodes. But is there? I mean, I don't even remember this, but let's experiment and see. Let's say 15 by 15 by 15. Shrink those weight down, and then I'm not sure. Okay, so there is. How do we do? How do we? A bunch of new data display options got added in. Where did those get added in? I thought there were additional ways of displaying data. I doubt it's a Mograph tag. That doesn't seem right. Well, am I thinking of like the polygon indexes and the point indexes? I don't feel like that's what I'm thinking of. Because you can do that, which is kind of crazy. So now we're seeing like the number, but those are just indexes. Doesn't. Yeah, we can say display. Okay, well, here's this. This is an older thing. I think maybe I was thinking of these new bits of data, and I was mixing them up with our traditional transform display. And here you can output the index, the UV, the color. And so, for your purposes, for your question, where you get confused with the way these things are adding, the only two ones that can potentially give you any information you're looking for, I think, would be color and weight. Where if we said display the color, now you see we get this dot. But maybe let's try weight, because that would just give us like a percent. Actually, it's just giving us a visual percentage. So, but how different is this at the end of the day? So this is all about the weight of the clone. So if I were to make a plane effector, and let's have it not do position and not do anything with color, but down here you can see we have a weight transform. So I'm pretty sure if we drag that up, yeah, you see the color there is changing. So now you see it's 100%. So now we can see this visually represented going from red meaning 0, yellow equaling 100%. And now I could make a field and make a linear field here. And let's make our matrix endpoint at 200, just so we're kind of perfectly fitting this box. Actually, it's probably 400. Nope, it's 200. Okay, so now we're perfectly inside of here. So now if I were to make a second linear field, and this one I'll say on plus y, we'll go into our field and layer it on top. So now we have two different ones, and we can start telling them how they mix. Right now, the top one, this later one, is completely overriding it. But we could say set this to overlay, and now we can see, one is fading up and then the other one's fading across. And now I think, let's go and view this perfectly from the side here. And now you can kind of see where, especially as I zoom out, where it gets a little bit thicker, you can kind of see where these two are interacting to be an overlay. And then I could say, but now set it to max. And now you can see the way they're overlaying, where it's like, it's taking the maximum value from either one, and then that's what gets displayed. Like the highest possible value of all of the available options. And then the min is the lowest possible value from either option. Add was going to add them together, which is different from max. Add and max are similar but different. You'll see a slightly different pattern. Subtract, similar idea, very different output. Screen and add for a lot of purposes are probably near identical. I actually kind of forget the difference between, but you can see the screen, actually add is a little bit stronger. Screen is a little bit less. I'm trying to think of the difference between them mathematically, given the values we're feeding in. But yeah, there it is represented as the weight. Along those lines, we could have also represented these on like a vertex map and also done a similar thing. And potentially you could be doing the same things if we told the matrix to be displaying color. And now we'll say that this is now not affecting the weight. Instead, it is affecting this color with field color. Then now we can just use the colors as determined by these fields, in which case I would turn this into a gradient. And I'll turn the other one into a gradient. And now it's the exact same idea. Now we can go into our field list and say, that's what it looks like when they're screening. Here's what it looks like when they're multiplying. Here's what it looks like when they are overlaying. And you're going to get these different patterns. So it's a good way of kind of, giving yourself some feedback and seeing mathematically how they are combining and the ways different colors are potentially combining. Change our color remap to something like a rainbow. And that could also give you some information and some interesting results. Like there's max. I'm curious what overlay does here. Yeah, overlay, darks, when darks overlay on top of darks, they become even darker. When lights become overlay on top of lights, they can become lighter. Subtract, screen, add. Yeah, screen and add are still very similar. But anyway, yeah, that's the only way. Yeah, well, that's the primary way I would think to get additional information of what's going on. Now we are here in three-dimensional space. Something that's kind of cool. I did this the other day for an upcoming plugin, but I had to display. Oh, how did I do it? I need to see like the RGB spatial values or something. So I loaded in a simple gradient. And then I think I went from pure, let's go here. So pure red to black. And then I'll delete that one, copy it in, and then say this one will be pure green to black. And now we change the orientation. I'm just guessing orientations here. And then we'll make a third one, and I'll say it's on Z, and we'll change its color to pure blue. So now we have RGB inside of my plane. I will layer like RGB on top of each other, add them on top of each other. And then we end up with the like every possible color like in the rainbow. And this gives us a ton of information. where it's like this has zero information or zero color value, and this one has 100% on every channel, and we get pure green, we get pure red, we get pure blue, and then the ways that they combine with each other. And it's almost like this is how UV maps, or this is how like normal maps work, is like we have all this directional and placement information thanks to these three overlaying on top of each other. Anyway, just kind of an interesting thing. I'll save it just because why not? But I don't know how applicable that would be to anybody. Yeah, RGB. Yeah, let me know if I actually kind of answered your question or if I didn't. If not, I can try and add to it. Oh, Travis snuck in with a question a little bit earlier. Can you do a radial slice using slicer? A radial slice. Oh, I think I know what you mean. And no? No. I don't know for sure, but when the best way I can visualize to try and communicate if asking if this is what you mean, it's kind of like when you have like an apple, when somebody has like an apple on those old timey apple peelers and they spin it, it's kind of like a spiral slowly working its way down the model. Then yeah, there the answer is no. And then how would you even return the information? I'm trying to think of any rig because there's I'm just going to visually experiment in a very simplified form. So we'll make a traditional landscape, which is the thing people end up slicing most often. But then here's kind of to visualize the cut you're talking about, and still slicer cannot do this. Let us make a helix. So we got the spiral, and I'm going to have it go upward, and we're going to increase the radius until it's kind of capturing all of this. We'll do start and end radius there, and I'll spiral it around a bunch more times, and let's give it more points. And then we make another helix, and this time has a radius of 0, 0, which looks like a straight line, but it's got all the same information as these. They're just positioned differently. And that means we can put this into a, I think into a, no, not a lathe. We can put this into a loft, and they should loft between each other. And now we have to give this a ton of sides. I don't know how many. Let's say 222. All right, let's say 2000. Okay, now we got a ton. So now I turn this on and say, okay, well, yeah, we're seeing something. Let me get rid of some of these subdivisions. We don't need them. Okay, so it's like, okay, well, what are we seeing? Well, we're actually seeing this thing spiral all the way around again and again and again. And this is essentially one continuous line, kind of like a slide. If I were to, let me give this inner one a bit of radius, and then we can kind of visually be able to tell what you're seeing. So if I do that, you can kind of imagine this as a continuous slide going all the way down. But if I set the radius to 0, then essentially we get this solid core. And then the question kind of goes to, well, what would the intersection of these two things look like? But I don't think we're going to get any useful information out from like a bool. So if we Boolean these, but see, it's just like one of them isn't the volume. So yeah, that doesn't do anything. A subtract B, I don't think that's going to return anything. Intersect. Okay, intersect does something. So yeah, okay, what that has successfully done is it's returned a cut where they intersected each other. So there is this new line that in theory is kind of a spiral. It's entirely possible because things kind of go up and they go back down again. They go back up and down. That it's kind of like the line will go down, up. Like, I don't know. But my question is, we can make this intersect edges, which is now output a selection. In theory, that selection is that new edge. So if we were to make a mesh to spline, I don't know if we can see the parametric version here, but I'm going to link into our Boolean. I'm going to override our point cap. Let's limit to a selection, and the selection will be the outputted selection from there. And then we visually hide that. And no, unfortunately, that's not returning that live. I think we'd probably have to make it editable to be able to see. Actually, I'm hit undo, bring that back again. I'll make a duplicate, hide that one, make this editable. And yeah, that's no good there. And now there's all these crazy selections going on. I'm going to double click on each one of them. Oh, okay, that one is the cut one, and it's just called I. But you see the selection started calling it ER2. Don't understand that, but I'm going to do that and hide that. And there now, that is the radial as extracted. But I can already see, yeah, we got some odd things. Like the main thing that's throwing me off is this. That's just terminating there. Is that like the only start? Why is that there? Oh, actually, maybe that does make sense because these other ones are traveling up. But anyway, I'm very curious to see if we made a trim. I'm gonna search for trim. So here's one of the Rocket Lasso modifiers. I'm gonna make a trim spline modifier. Drop this on here, and if I start pulling back on the trim, yeah, you can see at least this one big segment is successfully like one continuous spiral line. What's crazy is even though we just put that extra effort into making it look like a spiral, kind of like from a distance, there's no like it doesn't look like it's a continuous line. It looks like it's a series of individual cuts going through it. Now I am curious. I think it just goes to like the way these hills overlap. I said maybe there'll be some weirdness as this kind of undulates up and then back down again. So it's kind of like it's passing up one layer of the slide and then back down through the layer of the slide, and therefore they get sealed off or cut early. But it is interesting. Yeah, I think it passes up and then back down through the slide. I can't 100% account for that, but yeah, there's kind of the spiral cut. We can throw this into a circle just to do it. Let's delete that. Well, let's keep the landscape just for the reference file for people. Oop. Mesh to spline. So delete that, delete the landscape, turn off the bool, reactivate the spiral, make a sphere. I'm going to scale it up until it pokes out the top and then scale it back down again. Make sure it's not poking out the bottom, which it is. So I'll grab my helixes, move that to the bottom, make it taller. Yep. Cool. And do the same process again. Let's get the bool going. Taking a little bit to calculate, but oh wait, it's not taking a little while to calculate. It's not in there. Boop. A subtract B, B subtract A. Huh. Is it? Well, either it's taking a long time to calculate or it doesn't like this one. I'm curious that it was able to handle the landscape, but it's not handling the sphere. And it was the landscape and then the loft. And if I turn that off, yeah, we got that same shape. I try scaling it a little beyond the bounds to see if that makes some sort of difference, but no, does not. Now, is it possible it's just like a bad bool and like I put a different random scale might actually catch it? Yes, possible. Let's also try changing the sphere to be in the triangle-y circle or sphere. Yeah, it's just not liking that one. I don't know how to account for that. The landscape one worked. I kind of wanted to get the spiral on the sphere, but that doesn't seem to. It might be that there's some sort of deformer that would kind of get us the shape. I mean, honestly, a spherify would get us there on a sphere, but that's to me not terribly interesting. Where's our spiral helix? Let's grab that one. So we get that helix, and then we can make a spherify. Drop that on and crank that to 100%. Set our radius. Actually, we'll leave that 200 and reset this back to default, which is 100. So we'll say 200. Okay, so we get that. And now we do have a spiral, which is kind of sticking onto it. And then it just turns into a question of adapting the height. And so if I make this like, if I move it down enough and pull it up enough, you can see that the spirals get applied. What's interesting is that you are going to get this pattern where it's kind of tapering. It's getting tighter as it goes up. But that makes sense just because of like the way we're kind of crossing over the horizon on this sphere. But yeah, now you can see that that is a helix wrapped around a sphere to give you the basics of what you might want there. Potentially, you could adjust this in a bunch of different ways, but that's getting meticulous to the extent of not being useful. Potentially, we could remap our height bias to work there. I'm trying to think of other ways I might trace that out. I'm trying to think of some sort of constraint way of doing it where we would constrain it to the spline and then tell it to constrain to some other shape and it would jump to the nearest point on that shape. But that wouldn't work in most circumstances because like the landscape, it's not, we don't have the option of jumping to the closest thing on a particular plane. It would be the closest thing on the entire model. So that would not work. Yeah. Welcome, Rev. What's going on? But yeah, although Travis is very cool though. Okay, well now reading back to Travis reiterate or restating his question, asking about apple slices. Let me read the original question. A radial slice using slicer. Okay, so it turns out that Travis was asking a completely different question, although hopefully some people found what I just did interesting here. So let's address the completely different question, which we can do in a slightly roundabout way. And let me demonstrate that. Let's use a slightly different shape. Actually, no, let's use a donut. Make a torus shape. So what if we, I mean, obviously we could convert this to splines and that would be a super valid way of doing this. But let's say we wanted to use the Rocket Lasso slicer. And I'm going to change the orientation to be on Z+. Let's remote into an object of the torus. And now you can see it's making a bunch of slices kind of along the model. Instead, I'm going to say, we'll make only one slice, please. And where is it? Is it perfectly lined up or something? Oh, I think it was perfectly. It's like so perfectly on that line that we're not seeing it. So let's visually hide the torus, and there we go. Now you can see we got this singular cut. Now, of course, it's not actually a singular cut. It's a cut across everything, and that's what slicers does. It just does a cut across the entire model. But let's say we want to do a series of radial cuts around there. This is as simple as putting into a cloner. So if I put this into a cloner, and I can now say, I guess I'll just say radial. So I'm making a radial cut. I'll drop this down to a smaller radius. And now you see that I'm actually cutting this shape into these radials. Now the torus is so uniform that that's actually not that interesting. So let me show you, just kind of showing the concept. Instead, let's make this cube. And I'll say I'm cutting the cube. So now you can see we've got a single cut along it. Let's hide that, which I should be able to do this by clicking. Yeah, that hides it, but I guess I want to make a display tag, use lines. Okay, so you can see we get this one cut. But now if I do this radial, you can now see that we are cutting it on every step along this radial. Now, one thing you're going to want to do is the cloner, if you put an even number, because we're cutting one side and the other. So if you type in an even number, it's going to kind of make the line twice. So you see if I do this, it looks like there's less lines. That's because it's kind of cutting one direction and then it's cutting the other direction. So make sure it's an odd number. But now I'm doing a radial spiral cut on this. Now, the cut is not from the center out. It is an entire cross section of it. So keep that in mind. But this is not, this is not actually limited to just doing a spiral. I mean, we could make additional shapes here where you can see I'm making a bunch of different slices all on the surface. But instead, we can set this back to linear. I guess I'll save this one because this was the actual question. Radial cuts. I'm going to put this back to linear, and let's make there be no gaps. Now we can say how many do we want? Let's say like 11. And then we'll make a random effector. And now I'm randomly moving those around, which is cool, but I don't care about the position, although that's valid. I want rotation. So I'll type in 777, get pretty much total randomness here. And now I'm getting all these random cuts. So I can just keep on increasing this. And I've got singular lines that are doing a cross-section cutting across the entire thing. And we've kind of got this thing kind of all woven up. At a certain point, it kind of starts looking a little bit like Ricochet might if we were traveling perfectly on the surface. But this is stylistically different in that each of these is an independent line. Connect, don't weld, do a sweep, make a inside, drop the radius way down. So yeah, each of these is like a completely new separate cut, but it's kind of cool where you can make the model sort of emerge. You can make its shape show up just by how many cuts you're making. Like if we were to visually hide the cube entirely, it's kind of like, oh, what shape is this? It's like, oh, I can't quite tell. But as we make more clones, it doesn't take too long until the shape of the cube starts to emerge. And of course, this would apply to anything. Let's go and grab the elephant. Are we in models? Where's our elephant? We'll just grab the body and slicer, look at the elephant. Brink. And now we've got all these random cuts that, you know, where we are starting out is relevant. So we might grab our cloner and say, hey, scoot this up. And we could even go back to random and yes, give it some random position. I don't know how much we want to do. Let's say about 100 is fine. So yeah, random position, random rotation. And now we've got this whole series of individual cuts all chopping through, wrapping up the thing. And, you know, again, making the model emerge and making a very unique kind of shape, like this whole thing wrapped up. Each one is a single rope. Imagine we just snapped a bunch of rubber bands around them is a good way of thinking of it. Each one is a singular loop, all wrapping around. Take that and throw it instead into a volume builder, volume mesher builder. We're going to be dropping that way down. Grab the radius, increase our density, drop our radius, drop our voxel radius. And now all these are kind of webbing into each other. Make a smoothing deformer. Drop that as a child of the mesher. And now you can get kind of this liquidy web looking thing going across here. So yeah, another technique that you can do with Slicer that I think I talked about in some video somewhere that you can. We had originally thought about if we wanted Slicer to be able to do this like by itself. And it's like, no, you can do the technique with a cloner. And essentially Slicer has to do a lot of calculations about like figuring out which point is above another point in order to do optimized cuts. So essentially you got to imagine that this is cloning 145 times, or yeah, 145. So there's 145 different slicers in here, and all of those are each they're taking in the model, doing all the calculations it has to do to be able to slice it, making a single slice, and then moving on to the next one. But still, I dig the technique. It's pretty cool. You do a lot of pretty neat things with it. You can be kind of abstract with it. Let's shrink that down, push this up. The volume radius can probably go up. Yeah, of course, the volume size is always going to have a dramatic effect on this. But yeah, I think it looks pretty cool. I'll give that one a save as well. Random cuts. Yeah. So hopefully that answers a little bit more. Let's see. Adam, maybe the sphere. I don't think render. I think render perfect is like a render effect. It's not a object manager effect. So yeah. And NAS driver slicer only does straight cuts. Like this is as kind of crazy as we can go. The slicer is literally just being like, make a straight cut across this thing, like a samurai sword chops it in half. And that's what the cut is. Now, that can be at any orientation. It can be as many times as you want. It can be in any color you want, but it's always going to be a straight cut straight across it. So if there's no follow-ups on that one, yeah, I'm sorry, I wasn't checking the Twitch chat because the question came from YouTube. But yeah, some people were saying things like projecting the spiral, which I independently did. Concentric slices, Dean was saying, which is what we end up doing. Yeah, it starts looking a little bit toon shaded. And then it looks like we've got Mickey is putting in a question and somebody is seconding it. So, oh yeah, Lignazio, going back to the earlier thing about the color overlays and whatnot, is correct in saying that add, you can keep on adding things. So if you were to add 50% and 50%, you get 100%. And if you were to add 50% and 100%, you get 150%. They add on top of each other. Screen will never go above 100%. Anyway, let me click on this. Can you go about recreating this effect from the slow-mo, guys? Okay, I always like when it's not... I'm going to make this pretty tiny because copyrights will snag you for using other video clips. And currently, there's an ad playing. Oh, that's because it popped up in Firefox. I have YouTube Premium or whatever they call it, but that's in my personal account. Okay. Let's hop over here. So, like I said, I'm keeping it pretty tiny in the screen. Oh, goodness. Okay, so we got, oh, they're doing super slow-mo glass or bullet going through glass. Presumably, yeah, I can see there's already a bunch of panes of glass. This is a full-on, I mean, there's so many things going on here. We got all sorts of like shattering effects, layering. You know, so we've got particulate matter of the shattering glass. We got the actual broken parts. We got the entire thing fracturing and then eventually breaking further back in time. Well, maybe it was only one pane of glass. It was just reflecting a bunch of times because it was a single piece. So there's kind of like internal reflections. The interesting thing is like when you're doing a really high frame rate, like you have to put so much light on your scene. Although maybe, I don't know, it's hard to tell. There could have been more because you see they have all these notches in the wood. So potentially there was a bunch of panes there. I'm just curious. I'm going to rewind until... Yeah, okay, it was a bunch of panes. So they did a bunch and then they did one. Anyway, you can see that there's some pyro going on here from like the actual, like, you know, little explosion, the spark going on where the color of the bullet, or I'm sorry, the heat generated from the collision is actually creating some fire and smoke. You see this kind of ignition happening there. I guess a long story short here, there's so many things going on in here, and we could spend an hour just trying to make not it fracture and fall apart, but just make pre-broken glass that has this really nice kind of refractive effect. Like even that by itself is a non-trivial thing to do. So yeah, this is like a 5-hour question potentially. And even that like doesn't have the context of like, are we trying to make it in slow-mo, etc. Yeah, I mean, it even goes to me, it's like the second panes of glass aren't even adding that much complication. Like once you've got one, it's the other ones that take a while. So we're going to spend a bit of time on this. It's just, these things always end up needing like a ton of refinement and iteration. So I tend to think that it's like the type of thing that can make for a good tutorial because I've kind of done all the testing off screen and I can mostly tell people the final ingredients and the thought process of getting there. But I'm going to start out by trying to tackle, like I said, maybe the way that really nice refractive glass was looking. So we should immediately sort of go to real world scale here. So if we make a figure, I've got this pane of glass. So let's say that this is going to be about 50 by 50 and it's going to be real thin. So what was that? Probably like 1/8. So yeah, let's do 0.25 inches. Wait, what was that? 0.25 inches. There we go. So there we go. Pretty pretty thin. Maybe that's a 1/4 inch of glass, which is relatively thick. And then we can start. Okay, so I just want to look at some fracture things to start out with, which are things that are relatively simple. But let's go and that's not even to speak of like getting them to slowly reveal over time. So some thoughts. First of all, obviously, or the obvious thing to do is to put this into a Mograph Voronoi fracture. Now, what I want is a heavy concentration of damage in the center, and it gets out to be less and less. Technically, some of the source modes can do those types of things, but I want direct control over that. So we will do this with a matrix object. I will make a matrix. We will make it linear, so I can type in the exact number I want, and we'll say they're all at the exact same spot, and we're going to make the radius 0.2, so they're very, very small. And let's say that we're going to start out with 300 of them. So now I will make a random, and now the random is pushing them everywhere. Then I will say, actually, I want them to be pushed apart, how much, 5 inches? Yes, something like that. Ooh, let me think. I want an exponential-ish fall off. I have a technique for that. What is my technique? Well, this is just random, so maybe we can... Yeah, I think we can probably just do a step effector or something here. Anyway, I don't want these going out quite as far on Z, so I'm going to say, how thick was the last? 0.65, so we'll just say up to 1. So now they're kind of squished down. They're all here. Now, I probably want to push that out further, so we'll say like 15, 15. And then I'm going to go into the fields, and let's make that step effector, and let's see if this does kind of what I want it to do, which is we have now the ability to remap the step effector and say, how much is it being affected? So yeah, it kind of steps out. So this is actually kind of fun. I've never specifically done it this way, but let's go and make 3 times as many. You see, we've got a whole bunch kind of spread out. Let me even temporarily hide that. But now you can see there are a lot more clustered in the center than out on the outside. And we can remap that. If I just move in here and I say, hey, give me a curve, we can redesign this. And you see, I can say there's a lot more clustering in the dead center than on the outside. We could say, okay, wait, we want there to be a decent amount in the center, but there should still be like, I don't want too many at the end. So we can kind of get, we can perfectly art direct what we want this to look like just by wiggling these around. That's pretty cool. Now we are getting a square pattern. I'm trying to think if I care. We could do, instead of doing it randomly, we could do a spiral, which would be a completely different rig. So I'm just going to leave this square. There are ways of doing the other thing though. And then I think this is the type of circumstance I would totally use a push apart effector, because a lot of you probably know I don't use a push apart effector often. But now we can do something like give it a radius of 1. And now we can make sure that nothing's too close to any one, but I think even like 0.25. Yeah, that's enough to, you see this middle cluster, like a bunch of them are on top of each other. And now we're saying, no, there's a minimum distance you have to be apart from each other. And then all the rest are there. So that's, that works pretty well. Now, we might want way more of these. I don't know. But let's reactivate our fracture and go to sources, delete that out. And now we feed in our matrix object. And now you see we have a lot more detail breaking in the center than as we go further out. I'll keep making changes. In this random, let's push this further still. How big is our glass? I'll have them be able to go all the way out. So it's 50 by 50. So I think 25 by 25. Yeah, 25 by 25. You see they're almost going all the way to the edge. Maybe it'd even be a good idea to go beyond, but that works for me for now. Our minimum distance, thanks to our push apart, is, let's say like 0.1. Yeah, see, now we can make even tinier ones in the center. But yeah, sometimes this is a new thing that cinema's been doing that I just had never noticed before. Which is every once in a while when you change something, you're getting like kind of it is the right geometry, but you get some bad looking like fong on it. And if you just turn it on and off, it fixes. And it seems to be the Voronoi fracture doing it. I'm not quite sure the story there. But anyway, my goal here, in order to get those fancy pieces of glass I was talking about, is going to be we need to make a ton of these pieces and then remerge them so we get more complex shapes. Now, this is a 3-dimensional pattern here. So these cuts are not going to be perfectly perpendicular with each other. They're going to be kind of like tilted ever so slightly in different directions. Some of these might be significantly tilted. So why don't we immediately jump to these having a glass material on there, which is incredibly straightforward. And we're also going to need a lovely HDR. Let's go to all HDRs. I have found myself using this. I think I've been using this interior pretty often. So I'm going to pull that one in. Okay, cool. Yeah, we're inside the room. Let's get rid of these safe frames. Let's apply this material, go into it, and say, I think all we need to do really is crank up this transmission, and that should make it clear. And our refraction is 1.5, which is pretty much glass. I think, yeah, glass is 1.5, crystal is 1.55. And we'll just name it because why not? Okay, glass. Now we'll save it. I'm still Redshift hasn't crashed this machine, but I'm still kind of paranoid because it used to always crash the live streams when I was on the old tower. I'm just going to call this glass break for now because I don't know how far we're going to get into some of these different parts because we got about a half hour left. Okay, so let's activate Redshift, and I'm curious how it reacts even just to this. Let's give ourselves a little overview. Oop, well, it's hiccuping, but maybe it's just initializing. Okay, cool. Initialized, and there it is. I'm not quite sure about a couple of those little fellas, but let's explore. This isn't bad because we can see all the individual cuts and the different bits of refraction, but I'm not so sure about some of these black stripes. Maybe they're right, but they don't feel like they're right. Yeah, I'm kind of curious about that. Now, the first thing I'll do to kind of test that theory is let's make sure nothing is intersecting. And we'll do that by offsetting our fragments, even by something tiny like 0.01. And the instant we do, at the instant we do, they all disappear. So now there is technically a little bit of space between each one, where a second ago, a bunch of them were touching each other, which can cause those types of refraction like errors. Now you can see that problem I was talking about. Do you see up here? Like, look how that got all super messed up here in the viewport. And it's like, wait, what's going on there? But watch, as soon as I turn off the fracture and reactivate, it comes back. Same breaks, but it's not broken. So like, I don't know what's up with that. So anyway, much cleaner refraction. Like, it's pretty much looking exactly the way I want it to. It'd be kind of fun to get that blue glass effect that we saw in the reference. How do we do that? Is that just going to be like a little bit of transmission? Scatter color. Yeah, depth and scatter color, I think. Let's start out with make kind of an aqua. And then make a depth. Yeah, okay, immediately that gave us some color. 0.1. Okay, yeah, 0.1 is how thick it is. So you can immediately see it becomes very opaque. But if we say 1, then now it's become a little bit more. I'll say even 2. And now it's kind of like, well, like when we look at this at kind of an extreme angle, you can see that we start getting that blue effect. But I always like that kind of blue-green tinted glass. And now, depending on the refraction angle of some of our breaks, we'll actually get to see those little hints of green. So that's pretty much exactly what I wanted. Now, this is a pretty good break shape overall because we customized our vertex map. Like, I think it looks pretty good as far as a break goes, but I do want to attempt, and I think this will give us much better looking refraction, but I think it's going to really mess up our simulation if we try and run it. But so here's what I want to do. I want to start merging the pieces, and there's just essentially a setting for that. So I guess these excuse me. Okay, I think it's under, you always think it's under connecting, but it's not connecting. It's geometry glue. So I'm going to activate geometry glue. And right now it's based on a fall off. I'm going to say I want it to be based off of clusters. And now it's going to make 5 pieces. But I'm going to say, no. essentially we need to always just do a little bit of math here. I am making a matrix object and we are making 1,000 pieces. So if I say I want there to be about 333 under geometry glue, 333, then on average, every piece is going to be made up of 3 pieces. We've divided our number in a third, which means each piece gets 3 pieces. So if I activate that, now you can see that we have more complex glass pieces here. And let's refresh that for the geometry. And now you can see that we have more complex angles on our geometry. And I guess say some of these are not looking amazing to me. But if we zoom in, there are certain little, like, do you see how like these all have a little bit of dimension and different orientations? That's kind of what I want to have happen. So we're going to push it further. So that means we're going to make there be 3,000 pieces. And now there will still be 300 of our final pieces to that. Wow, that updated really fast. I'm impressed. So now each of these has 10 times the number of pieces making it up. So they used to be made of 3 pieces. Now each one of these cracks is made up of 30 pieces. Let's go up to, let's do about 6,000, closer to 7,000. And then I'm going to say that the geometry glue is returning 1,000 pieces. So in general, each piece is going to be made of up to 6 or 7 pieces, but they'll be smaller overall. So yeah, that's giving us some more complexity. So that's not bad. So I'm thinking maybe we've got a little too much depth here. Like a lot of these pieces are oriented in very extreme angles where I think generally speaking, we want them a little bit more forward and back, which generally speaking is true. But we can fix this probably by grabbing. Okay, so I'm going to do this kind of odd. I'm going to give this 0. Let's stop the render. What I'm going to do is give this 0 depth, okay? So our random, we're going to go through this step by step. Our random now has no depth whatsoever. It's all flat. Now, what's interesting is when the push apart sees all of our geometry and it sees that all of them have exactly the same Z, it's not dynamically doing it, just like mathematically speaking. You can't push apart on an angle that they're exactly equal on. So the push apart is now pushing them apart 2-dimensionally. So we still get all that lovely separation where none of these should be perfectly on top of each other. In fact, because it's 3-dimensional now, I should be able to do something even like 0.2, just get a little more space pushing those apart. These all start getting a little bit even. So maybe I don't know what number is good. 1.1 or 1.5 I'll do, but these still get a little bit uniform. Maybe. Actually, we probably need more iterations because you see it's nice there, but chaotic here. So these have not gotten the push apart all the way that they want to, which is making me think that we want a smaller radius just to help with that. And yeah, we can keep on adding more iterations because like essentially what's happening is like these are all overlaying on top of each other. They try and push apart, but other ones on the outside, so they kind of push them back. And every time you push, everything's kind of getting scooted out a little bit, and every iteration is important there. Now, hopefully these are sort of pushing each other apart. But now that that's happened, like we can now call this one like random dot x dot y. And now I'm going to make another random. And we'll say the matrix is going to get another random after the fact. And this one is going to be random z. So what we're doing is we're saying first we randomly move on x and y. And then we push apart based on the x and y. And then we give it some extra randomness just on z. So we'll say 0, 0. And then I'll say that these are allowed to push apart like 0.5. So that should give us the depth back again. So just a little bit. You see now they're not pushed so far apart. And now we can independently control that Z. And the reason I had to split this apart was because the push apart just is exaggerating any movement. So even if I had really shrunk down the Z on this one, the push apart would have taken that and exaggerated and pushed them very far apart. So now the Z comes afterward. And because the other ones are already pre-pushed apart, this Z should not be creating any intersections. Anyway, that should all be fine. Let's go and reactivate our Voronoi fracture. And now I have an independent control to make sure that there's not too much like internal twisting of the pieces. I did want the twisting like explicitly, but I wanted less. So let's go and activate that again. Okay, cool. Now I'm still seeing quite a bit of twisting here, but now I can just grab my Z and say, okay, well, give me 0.1 of the twisting. And let's see if my theory is correct. Yeah, look, see how much more straight lines these are now? Um, so this is all about finding a balance between those two. And then I feel like we're getting all these really heavy, like deep blue lines, which is more exaggerated than I thought it would be. So I feel like we can, it's those highlights. So we can say that the thickness that we're anticipating here from the transmission, which we currently said is 2, I think we keep pushing that further. Yeah, you see, it's actually it's making the glass very very clear, but these angles are refracting in such a way where it's almost like they're looking straight through the side of the model, which is why they're becoming so green. So we can keep on increasing this, and I just want like a hint of it, and I'm actually getting quite shocked. Now I'm wondering if I'm missing something because as I okay, yeah. So now I've pushed it really far, but now I feel like they're probably refracting through multiple layers of it. So maybe we can only go so far with that. So I might just, pull back on like the amount of the color we're passing through. I just want like a hint of that blue. Yeah, kind of tricky. I don't know. Yeah, let me know your opinions on that. That's not quite what I was expecting. Oh yeah, and there's also some roughness there. I was thinking about that, but the roughness, the reflection roughness always translates directly into the roughness of the transmission. I don't want any roughness here. So yeah, that should be a little clearer. Now let's go in and take a look. And now, yeah, these edges are getting like real messed up, which in a way is cool, but in a way, I gotta say, I kind of liked it better when they were smoother. When we were looking at the reference, it looked like they were quite jagged, but at least artistically here, I think these are too jagged now. So we got options. One would be we can make more pieces. So if I double the number of pieces, there are twice as many pieces, but they are now each made of half the amount of components. But I think the main thing we need to do is go into the matrix and say, hey, we don't need quite as many, 333. And as we do, every time I drop this down, you see there's going to be less and less resolution on those pieces. So let's kind of, well, just for the sake of experiment, yeah, let's. Ooh, I kind of like that. So now that we dropped it to a low number, a lot of these outer ones essentially aren't getting multiple pieces at all. But in the middle, where there are a lot of different clusters, these inner pieces that are taking more of the brunt of the damage are getting more pieces that make it up. You see out here, that didn't get more than one, but in here, this one it looks like it's made of like 5. So that's kind of cool. I dig that. Yeah, let's leave that there. I don't know if this bad Voronoi in the viewport makes it bad here. Kind of didn't seem like it was, but maybe. Um, Justin, yes, we're shattering glass, but we're doing it step by step where we are sort of expecting. Well, we're trying to do like a slow mo bullet exploding thing. It's kind of crazy. Um, yeah, Dean, we definitely well depending on see where these are turning pure black. I think that could be the render depth. It could be inside of Redshift. Um, let's see, trace depth. If we actually let's go down. So if I go down to 1, do we get more? Not really. But if I increase it up to 12, do those go away? Or is that just refraction that's like perfectly cascading out? Yeah, I don't know. Now, another thought here. I mean, if it's not adding to it, then it's in theory slowing us down. So, yeah, so I kind of thought the same thing. Well, let's trace depth. Is there a separate setting? Retrace threshold system. Yeah, I think trace depth is probably the singular setting. If there's a different setting, let me know. Globals. Maybe it's this one. Do I have to do that one as well? Maybe. Reflection and refraction. Let's try increasing that to 12. And that to 12. Okay, yeah. Increasing this refraction. Oop, nope. Looks like I wanted both of them. Now let's go up to 24. 24. Okay, that doesn't go any further. But yeah, when these turn, if I drop it down to like 1, 1, you see everything's a mess. Now we say 2, 2. And now we can see through the simple ones, but now there's no reflections going on because we can only reflect 2 times. So yeah, as we start increasing this number, it's going to start looking better and better. So we can go up to 12, 12. And now this one that looked black is now like reflecting properly. So cool. So cool. Now, oh yeah, Justin, that makes sense. So we'd have to change. Wait, so do we need to change both? And then do we also have to increase that? That, I don't see a difference between that. No, that doesn't, I don't think we need that. But yeah, changing both makes sense. Okay, sure. Oh, okay. So this could be a bad idea. But one thing I want to experiment with is what happens if we try and bevel all of these pieces. I could see this kind of blowing up in our face, but actually, another thing I'm noticing that maybe some of the internal reflection stuff is messing up on is it seems like these complex shapes, it doesn't know how to shrink them anymore. Do you see that there is not a gap happening between those? There's a gap happening on these, which didn't get multiple pieces. So I think that the Voronoi fracture is incapable of offsetting fragments that have been glued. So let's get rid of that, and we could maybe try thicken, but I'm going to try. I don't know if this is a good idea. Let's put this into, I'm going to make a connect and then turn off the weld and then drop this in. I did the order of that carefully so that they didn't kind of explode on top of each other and get super welded and whatnot. Now I'm going to save it because I fully anticipate this not going well. But let's try, let's hit NB. Let's try making a parametric extrude here. And what I'm going to try and do is say use polygon islands. I'm going to give this like a crazy high number. And I'm going to say to extrude minus 0.01. So as soon as I drop this as a child of the connect, all of these are going to essentially try and extrude and shrink in just a little bit. It's entirely possible this horribly messes up all the Fong tags, but let's see what happens. Boop. Okay, they're calculated quickly, and now you can see that it does look like there's a little gap between everything. And now if we turn on a refraction, yeah, so now we got a little bit of gap there. I think it just kind of worked. So good. It didn't, it didn't take a million years to calculate, and it seems to have done a fine job. And the Fong, I'm not seeing any horrible Fong here. It's possible that there is some Fong issue somewhere, but it's broken glass. Okay, and then this might not be a good idea, but I also wanted to try and make a bevel. So let's try making a little bevel and try and bevel the corners, because that could look kind of cool to catch extra bits of refraction. So again, let's do these settings outside of it. So we can say the angle threshold. Actually, we can make that. These are all pretty sharp. So I'm going to lower the angle threshold, and we're going to say an offset of 0.01. Just being careful here. Drop this after the extrude. And okay, even that bevel didn't take that long to calculate. And you see I've got this lovely little bevel on all the corners. So now you can see even as I'm zoomed up, there's more kind of information for that to be working from. So if we zoom out, that should be catching like way more like highlights and just glints of like, well, areas that are extra dark, areas that are extra light is sort of the hope. Now, what if we made that proportional, which means, oh, okay, maybe that's going too far. The hope here was that this bit of geometry, it would be able to make some of the cracks like these bevels larger and some smaller, because now it's 10%. We can try lowering that way down, but that seems to push it a little too far. Like I'm trying to find an area that we can see it clearly, but some of these should be beveled just a tiny little bit and some should be beveled a lot more. But now we are getting some bad like geometry breaks. As I zoom out, they're harder to see, but you see like right there, that's just like twisting polygons that are not happy with what we did. Having said that, I have just a thought to try, which is maybe we can remove the n-gons. So if we say remove n-gons, drag in another capsule, and drop this in, and now all of these are essentially getting triangulated. We could have probably also done that from the Voronoi fracture, but I kind of like the extrude working from it. But now we have turned these all into triangles, and now the bevel has a better chance of working correctly, but there's a good chance it doesn't. I'm definitely seeing a bad one there, but it seems like there's less bad ones, so the theory was kind of sound. But the let's try giving ourselves a slightly larger fixed distance bevel. Yeah, I'm not surprised that the bevel is this. We're asking a lot of the bevel given the circumstance that we're feeding through here. Like this geometry looks kind of cool like this. Let me yank off the reflect the material. You see that we just got a lot of funky geometry here, and I don't expect it to be able to handle like all of this like insane nonsense here. There's a lot of like really nearby polygons and whatnot, and it just doesn't quite know what to do with them. So it was a experiment, but I expected it to fail. So we'll get rid of the N-gon, we'll get rid of the bevel. The extrude, surprisingly good job. So now we've got kind of step one, which is our final bits of broken glass. Now, well, I guess in glass almost, you have to go to incredibly super duper slow motion to actually see the cracks in glass propagate through. Like it's such a crystalline structure that the instant it breaks, it's kind of, it propagates through the entire structure of the glass so quickly that for all purposes, one frame, there's no broken glass. The next frame, all of the glass is broken. Because I was just trying to think of, is there any way for us to hide the breaks in the glass? Because right now we could just like turn on and off or do a hot swap of two different models of the glass being on or the glass being off to be like, here's pre-broken, here's post-broken, which honestly is probably the way to go. The really old technique that I used to use was you could fake it. You could fake it by, but it would kind of go in contradiction to a lot of the work we just did here. The way of faking it was make this not a cube, but a plane. So then we would be breaking apart in the exact same way we just did. We'd be breaking apart a single plane, and then we extrude the plane. So essentially you could pre-connect. If we connect this, what's the right way of saying it? Let me just show you. If we, I'm going to save it just because it's another dangerous thing to do. Actually, I'll make a brand new connect. But this time, here's the dangerous part, is I'm leaving this tolerance on. I'll shrink it down to like 0.01. But this is going to weld. Actually, if we turn off the extrude, as soon as I drop this in, we're going to weld all these pieces. Like, wow, that makes a big difference. Look, here's the no extrude. Here's with extrude. As soon as I drop this in, it's going to attempt to weld all these pieces of glass together. But that would still mean that potentially there's two polygons or at least one polygon traveling through the center. So I don't think it's going to look very good. So let's drop that in. It's going to look different, but I don't think it's going to look good. I mean, I don't mind the way it looks, but it didn't solve the problem. I think what happened now is there's just a single pane of glass on each one. So that single polygon is refracting, instead of two panes of glass close to each other, refracting each other. It's just a single pane. Looks kind of cool. I think it's less realistic. But it didn't make the cracks go away, even though these are infinitely thin now. So just to demonstrate, because it's not hard to do, let's make a plane, face it on Z, 50 by 50. I'm going to yoink out our cube and drop instead this plane in and turn those off. And we don't need the material. So now, what's going on here? Why is our fracture? Oh, what am I looking at here? Oh, sorry. I still have the cube turned on. It's just blocking our view. Okay, so now we've got all, like, not exactly, but we've got a bunch of cracks in almost the exact same pattern. So, oh, the other one was 15 by 15. That's what tricked me. 15 by 15. Oh, those are segments. Oh, and the width. Oh, how big is our pane of glass? Yeah, it was 50 by 50. I'm losing my mind. 50 by 50. Okay. So now we've got the singular pane of glass. And then if we take the end result of that and we put that into a welding connect, let's tell that one, I guess that one's the welding. So I'll tell that one to weld. Those pieces have gotten welded back into a singular piece of glass. If we then do something like, I don't know if the thicken works. I'm having some trouble with thicken lately. If we make a thicken, you're going to see that that looks like a perfect, what was the thickness? 0.6? Yeah, 0.6-ish. That looks like a perfectly smooth, perfect pane of glass. which is cool. Now, keep in mind, it's two-dimensional. And then we're adding thickness afterwards. So then, but keep in mind that they are, hit this, it is broken. It just looks perfectly smooth. So then if we start deforming these points to not be perfectly welded on top of each other, which, I have to, how do we do that? I want to think of a parametric way of doing it. I can't individually. I'm just gonna. You see, those are more complex. Essentially, I want to. I guess I can inset, but I can't inset with a fall off. Capsules don't work with fields. That's annoying. Well, this is all just supposed to be a demonstration of a propagation effect. So I'm going to do the fakiest fake version of this, which is going to look terrible with all these nice clusters, but I'm going to merely put a plane effector. Let's add a plane effector. Don't offset, but yes, scale in a uniform, absolute way. That's fine. And I'm going to say minus 0.01. So a very, very, very tiny amount of scaling down. And now you can see that these all, like the individual clusters have scaled down, but of course they're scaling down in a not nice way. So this isn't like doing that nice clean extrude. I'm doing this really horrible fake one. But anyway, there are now successfully gaps in between all of those pieces. But we are now doing this with a plane effector, which means I could make a sphere. I can make a spherical fall off and go to its remapping. Let's give that a full fall off. And the radius will go way smaller. So now if I start shrinking down this radius, you can see that, at least in this refractive viewport here, looks a little bit weird on the edges. But you can see that it looks like it's broken in the center, but it's not broken on the outside. Actually, given what we're doing, this makes sense because some of the pieces are welded. Some of the pieces are welded, like part of a piece is welded to part of a piece, so it's creating weird refraction. But these ones that are completely unwelded are suddenly kind of revealing themselves, and then the outer ones are not getting scaled down. And so it's kind of like we could propagate the cracks here just by scaling up this thing. As I make it bigger, you see that more of the pieces look like they are cracking as they go through. So that's a way of kind of propagating the crack out. But like I said, I think in reality, pieces don't like it. Yes, it propagates out, but it takes like 1/10,000th of a second or something. So I don't think we'd see that. I think it just goes from not broken to broken is actually what's realistic. Potentially, we could explore more methodologies to make it propagate through, but given our goal here, that actually doesn't help us. Don't do that. Don't do that. Yes, do that, that. Okay, now we're back to the glass as we had it. Refresh that. Yoink. All right, let's slow down. I think we're not giving it time to process. Boom, that's it had been those calculations had been happening pretty dang quick before. Boop, boop. That's not welding. No, that's not welding. There we go. Okay, we're back to where we were before I started messing around with the plane, just to kind of explain that alternative methodology. So now we're back to these pieces being able to have a little bit of an angle to them, which we put a decent amount of effort into making those be able to do that based on the reference. Now, we're almost out of time. This is where I said, like, there's so many parts to this that, could take a, 5, I said it was a 5-hour project. Now, in order to kind of like boop this stuff away, I'm just gonna make a cylinder. The simulation gets tricky for several reasons. Now, technically, none of these pieces are touching each other once it's shattered because we kind of shrank them down. But I don't know if bullet, and we're definitely using bullet because it's more stable. I do not know if bullet is up to the task here. It's not going to be a perfect bullet shape, but I will give it a little bit of rounding. Okay, so if even here, let's say we are doing this in slow motion. So, and then I'm not caring about the animation right now. Let's just see what we can sneak in. So there, and then we'll do super slow. So it's gonna take like 75 frames for this to just go like that far. So we're going real slow, and we're going linear. Okay, so boop. So it's gonna be doing that. Now we save this as the next scene file. That becomes a bullet collider body. And technically, if we want this rounded shape, then we want to make sure that we are saying that's the trigger. The collision is going to be not automatic, but a convex hull. We can do convex hull, which is quicker to calculate. And then our Voronoi fracture, we disconnect is welding them down. If we want to run simulation on it, we need to pre-explode the pieces. So ironically, we had to bake it down to do the extrude, and now we have to turn it back into a cloner again, which I will do by making another Voronoi fracture. This is very silly. But I think there's method to this madness. At least I hope there is. So I'm deleting all the matrix stuff, the sources, which means essentially this should break this apart into pieces again, and actually did a good and quick job of doing it. So now it's back to being a fracture, but it's a fracture, or essentially it's a Mo object, doing it. But the extrude is now applied to it, which we couldn't have done in the hierarchy unless we baked it down. Now that that's a Mograph object, we can now apply another bullet, but this time we're going to apply a rigid body tag. The shape is definitely going to be a moving mesh, which is the worst type. That's the slowest. And first of all, let's turn off gravity. Bullet, gravity, 0. We're probably going to want to decrease the time scale, but let's not worry about that quite yet. And also, I have to imagine we have to drop down this collision margin and scale, but I'm going to hit save. Well, let's just see what happens. Hitting play. Let's see what kind of ballpark we're living in. Yeah, a ton of those shapes are counting as colliding with each other. So should have already paused it. Not as bad as I was worried it would be. So let's start out with our collision margin. 0.001. Very tiny, about as tiny as we can get. Let's see if that counts. Yeah, now you see they're not pushing apart from each other. Still takes forever for it to calculate. I'm going to increase that to 0.01, which I think is what the extrude was doing. Is that enough for these to not be intersecting? Yeah, okay, 0.01, enough for them not to be pushing each other apart directly. Now our bullet can do its thing, but you can see already like our frames here, like we are throwing a lot of pieces at this thing. But hey, that's what the assignment calls for. So already you see it's doing a fine job. Let's visually hide the matrix. And you can see already these couple of pieces are pushing apart. As soon as we make contact would be the moment that we swap out one type of glass for this broken type of glass. Because the shatter would essentially perfectly happen. I mean, honestly, some of that transitional stuff is so hard that I'd almost be inclined to render out, if you wanted to get a little bit of a couple of frames of it transitioning out, I might even be inclined to render it as a solid painted glass and then render it again with it broken, and then just do a crossfade, just animate a mask going across to imply it going out. That would be so difficult to do that in 3D. So yeah, that's now going to pass through. Now everything is moving very slowly just because the bullet's moving slowly, but in theory, we could also decrease the simulation. What do you call it? The simulation time scale, so that all of that would also want to calculate slowly. Let's pop open Redshift and just see how our refraction looks as the bullet's kind of pushing these to interesting new angles. Honestly, not that different. I mean, it is pushing them out. If we go to the correct angle, that looks pretty cool. Those pieces going out. But even here, given how zoomed up we are, it's making me want there to be even more pieces broken in that very, very center spot, because like it feels like those should be like tiny, tiny, tiny little micro pieces, which we could do. I mean, even the rig as we built it, you can see that we got all these pieces cascading really, really far out. So if we kind of go back to, let's simplifying, I turn off a bunch of those because we don't need all those calculations. If we go back to, actually, we could even turn off everything. We just go back to our original matrix, and here's all those pieces. But if I go back and say, hey, I still feel like the push apart's got some value, but I'll say 0.025. So 1/4 of the push apart it had been doing. And then our is the, oh yeah, this is probably, yeah, that's also got step. The Z doesn't need that step out, but the X does. So we could remap this. And keep in mind, we're just looking at the distribution of these matrix objects. What do you want to do? No, that pushes them out. So we actually want this to be incredibly flat. So we're kind of saying the lion's share of the pieces are very, very near the center. So now you see we got the little itty bitty pieces there. And this is all just a balancing act of how we want to remap this. But this is why we build these rigs like this, is because I can just go in here, remap the spline. I have a completely different, like, shattered glass effect. So let's reactivate that. Calculate super quick. Now we have even more. I thought that would actually be more complicated, but yeah, even more pieces there. It's actually calculating surprisingly quick, so I think we can do this interactively. So I can pull this handle back even further, tick it up just a hair, and flash our Verona on and off to fix the errors. Turn off the bullet for a moment. Yeah, we get these tiny pieces. We could tell it to weld the pieces together less. Of course, I will make more clones, which will be more calculation. But yeah, some of those are just not as tiny as I want them to be. So we could go to the glue and make there be even more pieces, or we could even try turning it off. Now you see how now you see how many pieces are actually there. So now we're getting real itty bitty. How many are we making? Matrix. We're making 2,000. Here we're making, yeah, I mean, that's implying that we shouldn't be making that many clusters. It's kind of curious. If I say 3,000, yeah, it still does make some clusters. That doesn't even feel like it's changing much, honestly. I mean, we might be putting this cluster algorithm to its limit. Okay, if I go to a really big number now, these tiny ones do get a little extra detail, but you see these outer ones are losing detail. Potentially, we could do this instead based on like a fall off, which, yeah, I'm a little fuzzy on that, but we're going back to this being a little less as these individual fractured pieces, which, I would like to keep them in those fractured pieces all the way through, but, let's keep it going. So now we connect them, extrude them, re-break them, bring back our bullet, and now we have these little itty bitty pieces where it's going to be colliding. Now, I thought that these pieces would be doing a horrible job. There are more pieces, so I think this might take even longer to calculate. But I thought this was going to do a horrible job of one piece was going to cascade and hit the next one, next one, next one, next one. But it's actually doing a really good job, to the point where I almost feel like we would have to do some additional effects on top of this to force more pieces to go through, because I feel like it's doing such a clean job. And this is why I do like bullet, because, well, anyway, in my head, I completely understand what I'm seeing. So as I let this go through, it almost feels like some of those drifted before the bullet got there. Maybe, maybe not. But yeah, as this hits, I feel like many of these aren't going to move at all, and only the ones that we directly interact with are going to move, which is good for precision. I'd rather that than not that. Yeah, so those are starting to break out nice and tiny. But I'd probably put like some sort of force on top of the bullet so that we kind of get like a big indentation going, like a cone shape pushing out, just so that there'd be a little bit more dimension here. But having the centerpiece really push out is essentially what I was just aiming for. This is why we just went back and made there be more tiny pieces, because before I feel like this was a cluster of like just a handful, and now there's way more. This is all about the angle too. You do that, and now we get this nice break right there. So that'd make for kind of a cool shot. Ooh, look at that. That looks really nice. That might be the nicest looking kind of shattered glass I've ever done. I feel like you can kind of feel the shape bending out, all the little refraction, seeing the green through there. Look at all of the look at how much clustering is going on in these little pieces. That is way too much. Just out of curiosity, I guess we can rewind to do it, but let's just say there's no glue. Get rid of that. Now we get all these real, give a second, it's propagating all the way through. Now we get all these really tiny pieces. Now, the good thing about that, if we did leave it, I mean, we did just kind of invalidate a lot of our work for all that cluster checking we were doing. But if we leave it that way, we can now go back into our bullet simulation. And instead of saying moving mesh, we can go back to convex hull, which is a quicker calculation mode. Because all these shapes, Voronoi fracture, unless you do geometry glue, it's making convex hulls. Essentially, there's no divots inside of it. There's no indentations in any of these pieces. And it's a lot easier for cinema to calculate what the shape of it should be if there are none of those. Now, there's going to be even less interaction between these pieces. But yeah, give it a couple frames, let that collide. We didn't make the cone force to collide with it to, push out more of them, which I think would look really nice. But I feel like it should have collided by now. But I'm not seeing it at all. Nope, it's only just getting there. Got to be patient. Do it. Bink. Remember, you saw all those little tiny clusters. I mean, that's what we told it to do. So there's gonna be a ton of tiny little pieces there. What's cool about that is like potentially, like originally I wanted, and I guess you still would, but it's like potentially, this is where I said this would be really complicated, 5-hour project, is that, yeah, we get this initial glass shattering, which is cool, but I'd probably also do a particle simulation here to have like little shards of glass come flying out in addition to what the bullet is creating. But getting these kind of like real pieces is pretty cool. Now we are pushing, well, you see how slow that's starting to go, but yeah, you see they're like all these tiny little pieces. Looks cool. Pull this out, yeah, little pieces getting separated out. I dig it. But we're 10 minutes over already, so if there continues to be interest here, we could, potentially continue here. Maybe it would be kind of an experiment, but we could save this file here. I'll save it the next version, and then we could, if essentially somebody comes in and they're like, hey, please continue the glass project, then we can say, okay, we'll continue it, and it'll be in a different episode, like a part 2. So this is like the glass break part 1, and then we can do a glass break part 2, which is potentially like making the bullet look nice and making the shockwave, the force to indent the glass more. And then we've got the actual particle stuff and then we'd have all the pyro stuff, and the pyro stuff's got like layers and layers on top of that as well. But all those things could be built and layered up on top of each other in cinema. But I do think that's where I'm going to have to wrap that part up for today. So I'm going to announce, actually, I should probably check the comments just to see. I'll leave the glass up while we're talking. Yeah, that's fine. No point on that. That's all good. Why they glued together? Yeah, they glued. Oh yeah, Tobias, thank you as always for putting in the posts. Here, YouTube, I'm copying this over to you. Here is a link to the Rocket Lasso Slack. So anybody wants to come and join us on the Slack, you can do that there. Well, yeah, I scaled you saw me at some point scale the Voronoi pieces down. But it's a dumb scaling. It wasn't like the extrude. I consider the extrude a smart shrinking, where they're all shrinking down on every single facet of their, every angle, every little polygon is pushing inward. Where scaling with Mograph, it just scales them down uniformly as like a dumb object. And if you have like two C shapes, and then they start each independently shrinking down on their own angle, then they start passing through each other. So that's a limit. And Emiliano, asking what if we use the other simulation engine. We could do that experimentally next time if we want to put in here. I'd probably dramatically decrease the number of pieces here just as the experiment. I don't think it's going to hold up very well. There's just a lot of geometry here that's very tiny, and it doesn't handle a lot of polygons very well. But nothing I saw here really called for the need for all the stuff to be super interactive with each other. But anyway, I do think that's going to conclude this one. The next week, Jonathan Winbush is going to be a guest, so we're going to be talking about C4D to Unreal. So everybody's coming to hang out. Make sure you have your questions good to send Winbush's way. That's going to be very important. And for the most part, I'm going to be ignoring questions that are Chris-only questions. So make sure you're targeting like things that Winbush would be familiar with as well, as we typically do with guests. So yeah, looking forward to that. Everybody make sure you tune in for that one at the same time as usual. But I think that will wrap this up. Thank you so much, everybody, and I'll see you in a week. Bye-bye.